the blue part of the visible spectrum. Light is a mixture of lots of different colors. The blue color gets scattered a lot, which is why when we're standing on the Earth and we look up at the sky, we see a beautiful blue sky. That is blue light from the sun getting scattered in the air by the Earth's atmosphere.
And we can already see from our tile, from our moon up in the corner there from Griffith Observatory, that it's actually starting to turn a little bit red because we're edging in towards the total phase of our eclipse.
Right, so we are just a couple of minutes away from the start of totality. So we are now going to start to see this reddish color. Any part of the moon that is already in the dark part of the Earth's shadow will already be this red color, but we can't really see it from here on the Earth until the whole of the moon has been covered by the Earth's shadow, because when we still have that little bright crescent, our eyes cannot adjust to the contrast, and we simply cannot see that red color until the whole of the moon has darkened, and then this color becomes apparent. Again, we've just switched to our picture from Morocco, and we can also see there. Yes, we can start to see it is. We are beginning to see this this little red color. Yes. So going back to what is happening in the Earth's atmosphere, the first thing is that the light is being scattered. Blue light is being scattered away, scattered out of the sunlight. The second thing that is happening is that sunlight is being bent. This is something called refraction. It's something you can see if you have a glass of water and you put a drinking straw in it. You can see that the straw appears bent as the light comes from the air into the water and out into the air again. It's bending, it's changing direction, and it gives us this very bent image of a drinking straw in a glass of water. Well, the same thing is happening to the light from the sun. The first thing that's happened is that all the blue light is getting scattered away, so it's becoming reddish. And then this reddish light is being bent by the Earth's atmosphere, and it's being bent towards the moon. So even though the moon is hiding in that dark part of the Earth's shadow, even though the moon can't see the Earth directly, the Earth's atmosphere is bending this reddish sunlight around the Earth and sending it towards the moon.
Is it always red?
It's it can be a variety of reddish tints. It does depend on what is happening in the Earth's atmosphere. It depends on the situation with clouds. If there have been things like volcanic eruptions which throw a lot of particles up into the Earth's atmosphere, this can affect the scattering of light, and it means that the color of the sunlight that is being bent towards the moon can take on different shades. So sometimes it is a very pinky red, sometimes it's a very muddy brownish red. As we are looking at the pictures here, it does seem on these pictures to be a slightly speckly, because of course the colors we're seeing on the screen here, these are dependent on the equipment that we're using to bring you these pictures. It depends on the camera and on the filters. But yes, every lunar eclipse does have a slightly different shade to it.
And we're coming up towards pretty much the totality now. How many minutes left? We've got a couple of minutes left.
Right, well, we are into totality now. Yes, totality began just about a minute ago. We can still see that the top right corner of the moon, as we're looking at the pictures here from Los Angeles, that's still looking a little bit brighter than the rest of the moon. That's because that part of the moon has only just moved into the full dark part of the Earth's shadow. But we are now into totality. The only light that is reaching the moon is this reddish light that is not reaching the moon directly. It's being bent around the Earth and sent towards the surface of the moon.
It's very cool. So now we're going to look at this for another hour to look at this becoming deeper red, you think?
That's right. So as the moon moves deeper into the umbra, as it moves deeper into the dark part of the Earth's shadow, yeah, we will see this reddish color change, and it should become a deeper red. In half an hour's time, we will be at maximum eclipse. This is the point where the moon is at its deepest point in the umbra. At that stage, we should be seeing a very different kind of